Augmented reality is changing the manufacturing world by integrating the digital world into your field of vision. Augmented reality offers the best of both natural vision and digital information. It can provide real-time assistance to workers in remote locations, help workers learn new skills, and walk technicians through a repair. It provides a mobile, intuitive way for engineers to interact with sensor data, digital twins, and their physical counterparts.
When we marry digital with human, which is what augmented reality or AR is all about, we get vastly more productive workers thanks to the ability of the digital world to monitor, control, and optimize the work of humans. You need AR to deliver all the digital information in a more natural way to your workers and to be able to digitally capture their physical work processes so that they can be reused and analyzed and optimized. Essentially, AR is IoT for people.
Automation, manufacturing, and design companies have started to pay attention and have begun to explore the value of this disruptive technology. Augmented reality certainly has the power to disrupt the way some industrial manufacturers operate, but exactly how are companies and workers adopting to this new tool? Before diving into augmented reality, we need to define how it compares with its sibling visualization technology, virtual reality. AR and VR are at opposite ends of the visualization technology spectrum. VR removes the real world altogether and replaces it with a digital one. The immersive environment can be photorealistic or animated, depending on the programming. VR hardware tools disconnect users from their environment by swapping headsets for the field of vision and hand controllers for touch. All the while, cameras capture and simulate your movement and location in the digital landscape. On the other side of the spectrum lies augmented reality. Basic AR applications use any device with a camera. Several use the powerful computing capabilities of today's smartphones and tablets to deliver some level of AR to the masses. For example, AR is becoming popular for smartphone gaming. In the world of manufacturing, the sweet spot lies in the middle of the visualization technology spectrum, where it combines AR's field of view enhancements with VR's sensor-driven visor headsets and hand gesture controls. Microsoft HoloLens headset, for example, houses a powerful graphics processor that overlays its surroundings with virtual images. This range from 3D reference models and 2D schematics and visual instructions to simulations and teleconferences with experts who use HoloLens cameras to view a problem. Users manage the screens with hand gestures that are captured by built-in cameras. This lets users interact with the digital world while freeing their hands to manipulate physical objects. Many headsets for manufacturing fall into this middle ground between AR and VR, letting users see their surroundings enhanced with digital information. And engineers are finding ways to put them to work. Its ability to reference CAD models, drawing schematics, and plant layouts in a real-world environment is useful for engineers looking to optimize a plant's layout efficiency. According to the IDC, 82% of respondents were positive about using AR in manufacturing. Their number one reason was to boost manufacturing efficiency, followed by reducing the time gap between training and operations. One popular use of AR is to lay out production lines. While engineers can do this using 3D CAD models, the representation on the display does not always reflect the as-built environment. An engineer might design a manufacturing or assembly line, only to find out later that a support pillar or low pipe makes that configuration impossible. The ability of AR to superimpose virtual equipment over a real-world space ensures a better fit on the factory floor. A plant engineer could simulate a production run to see how all the elements of the new line work together, or how a new machine might interact with already installed hardware. AR quality assurance enables engineers to validate whether a part was made correctly. They can, for example, compare a manufactured part to its 3D design model. While CAD models have played this role before, AR takes it one step further by enabling technicians to overlay 3D models with actual parts, making it easier to visualize any flaws. How far along are we from everyone having an AR headset in their tool bag? According to the IDC data, not that far, because AR's ability to quickly boost workforce capability brings a rapid return on investment. According to the IDC, 62% of respondents claimed a positive ROI from implementing AR. Also, 65% claim better knowledge transfer among employees, and 60% of them said it improved employee efficiency.